This is lesson 6.2, solving systems using substitution. Remember, a system of equations is any time that we have more than one equation and we're trying to find a solution that makes each equation true. So we just talked last lesson about how we can solve systems of equations by graphing. That was lesson 6.1. You can go ahead and watch that video again if you haven't. In fact, if you haven't watched it, you need to watch that one first. Now we're going to talk about another method for solving systems of equations, and this is called the substitution method. Let's think about what the word substitution means. If I'm absent and not at school to teach you guys, you will have a substitute teacher. This teacher will fill in for me. They'll take my place. Probably won't be as great and wonderful as me, but, I mean, you can only ask so much of a teacher. In math, it'll be the same type of thing. We're going to replace one variable with a different value. So here we have a system of equations. Y equals 4x and x plus y equals negative 25. Do we know the value of either x or y according to this equation up here? Well, yeah, it says y equals 4x. So instead of saying y, I can go ahead and plug 4x into this equation and replace that y value. So my new equation would become x plus, remember here, we're using this equation and we want to substitute in this 4x for y. So we'll say x plus 4x equals negative 25. Now, does this look like something we can work with? I think so. X plus 4x, that will give us 5x equals negative 25. 5 times x equals negative 25. To undo multiplication, we need to divide. So we'll divide by 5. 5 divided by 5 is 1. That gives us 1x. Negative 25 divided by 5. Remember, when we have a negative divided by a positive, that leaves us with a negative. So our answer would be x equals negative 5. Now, remember, when we're solving for systems of equations, we want to have our answer in a coordinate pair. So that means we want to have an x and a y. So now that we have our x value, do you see a way that we can find our y value? Well, according to this equation up here, y equals 4 times x. So if x equals negative 5, I can go ahead and I can say, well, y equals 4 times negative 5. We will get y equals, again, we do a positive times a negative, which leaves us with a negative. Y equals negative 20. If we go on ahead and write that as an ordered pair, we could say negative 5, comma, negative 20. And that is our solution set. It's very important to try to check your answers whenever possible. Fortunately for us here, we can easily check our answers by going backwards and plugging it into both of the equations. So I will say, I don't know, is negative 20 equal to 4 times negative 5? Well, I would say yes, negative 20 does equal negative 5 times 4. Then I'll check, so this one here, yes, it's a solution. Now I'll check my next problem. If I have x is negative 5 plus negative 20, does that equal negative 25? Well, negative 5 plus negative 20, yep, that is negative 25, so it's also solution there. So if you want to find a way to check your answer, that's how we do that. We go backwards and plug it into that equation. So that one was okay, pretty easy enough. Let's go ahead and we want to try another one. Sometimes it won't have one variable. It won't tell you exactly what it equals. We may have to do a little bit of manipulating to get one variable by itself. So anytime you have a system of equations and you're using substitution method, you want to look for a variable that's super easy to get by itself. Here, I'll have to do some division and some subtraction, and it just looks a little tricky. Here, my x value is already by itself. It's only 1x. So all I have to do is get rid of this minus 2y. What is the opposite of negative 2y or minus 2y? Well, the opposite would be plus 2y. So I'll add 2y to both sides of my equation here. And I have a new equation that says x equals negative 3 plus 2y. Now we know what the value of x is, so we can plug it in for this x value here. When we do that, we have 3 times negative 3 plus 2y. Notice how I put that all in parentheses there, because it's 3 times whatever x is, so we have to multiply it by that whole thing, plus 4y equals 14. So we'll solve it out. Whenever we have a number on the outside of the parentheses and we have to multiply it by an expression on the inside, we have to distribute. We have to multiply that term to both terms. So 3 times negative 3 is negative 9. 3 times 2y will be positive 6y plus 4y equals 14. Let's go ahead and we'll combine our like terms. We have 6y and 4y. So negative 9, 6y plus 4y will be 10y equals 14. We will add 9 to both sides. We have 10y equals 23. And then we need to divide by that 10 because it's 10 times y. When we divide by 10, 10 divided by 10 is 1, which gives us 1y equals 23 over 10. Now, it's a fraction. Fractions freak me out, so I'm going to check. Yes, I did my math right every step along the way, so my y must be 23 over 10, and I'm just going to have to get over it even though it's a fraction. Once I have my y value, I can plug it into this equation here to solve for x. So I will say x equals negative 3 plus 2 times whatever y is. That's 23 over 10. Now, when we're multiplying with fractions, remember first we want to give them common denominators. So I want to put this one over 10, so I'll multiply it by 10 over 10. That'll be a negative 30 over 10 plus, over here this is like saying 2 over 1. 2 times 23 is 46 over 1 times 10 is 10. Now, when we have common denominators, we'll keep the denominator. We have a positive number and a negative number, so we're going to go ahead and subtract. 46 minus 30 gives us 16. The negative is with the smaller number, the positive is with the bigger number, so we're going to keep it a positive 16 over 10. Can we reduce this? Yes, of course we can reduce it. We'll divide out a 2 on both parts, and that will give us an answer of 8 over 5 for your x value. So when we go and write that in to our ordered pair will be x comma y. So 8 over 5 comma 23 over 10. And yes, they are fractions, and yes, they are ugly, but the matter of fact is that is your answer. Now, just like with graphing, we have 3 different options here when looking at these problems. Sometimes you will get one solution, x equals something. That means that you will have one solution, then you need to go plug it back in and figure out what your y is. Just like with graphing, we can also have infinitely many solutions. That's when you end up with a statement that you're like, well, duh, 6 equals 6. Yeah, so your variable will end up canceling out, and you'll have it basically saying a number equals itself. Also, just like with graphing, you can have no solution. This is when you end up with a statement that's totally false. Negative 4 equals 7? Never. So that would be no solutions. Let's make it a word problem. A snack bar sells 2 sizes of snack packs. A large snack pack is $5. A small snack pack is $3. In one day, the snack bar sells 60 snack packs. So I'm going to go ahead and I'm just going to use the letters. Oh, let's finish it. How many snack packs did the snack bar sell? So I'm going to go through and I want to look through the important information. A large snack pack is $5. A small snack pack is $3. They sold 60, and they made a total of $220. That's all my important information. So let's try to make 2 equations. I know one equation is my large snack pack, we'll call that L, plus my small snack pack, we can call that S. That is going to equal 60 snack packs sold total. Then we'll go ahead and we'll write an equation with the money. A large snack pack is $5, so 5 times however many large ones we sell, plus $3 for a small snack pack, 3 times however small ones we sell, equals $220. Now, I want to give you guys the opportunity to go ahead and try to solve this for yourself. If having the letter S in there confuses you, get rid of it and put something else like B or X. But I want you to go ahead and try to work this one out on your own. In the end, your answer should tell you that your large snack packs, you sold 20 of them, and your small snack packs, you sold 40. So go ahead, work it out by yourself, test yourself, see if you understand what's going on. Alright, I hope this video was informative and helpful. And a joke of the day. What do you get when you cross a snowman with a vampire? Frostbite. Alright, see you guys tomorrow.